Hey everybody, Mr. Withers here. You should have your green 2D and 3D area formula study guide or graphic organizer in front of you. Should be on the front side looking at two-dimensional area formulas. The top of that sheet should look like mine. Please make sure you put your name at the top. We're going to talk through some area formulas for two-dimensional shapes today. So we're going to start here with a square. We want to make sure as we are looking at a square, we remember all the sides are the same. That's what these little dash marks mean, that those measurements are equal. We also know that all of our angles are right angles. Those are marked there as well. So with our sides all being the same, I'm just going to call each one of these sides letter S. So you can add that to your sheet. And the area formula for a square is just the side length times itself. You could also write this as area equals side length squared. So we take one side length times itself would give us the area of a square. So an example problem that you could have over here off to the side would be something like this. Maybe our square is a 3 by 3, and we'll call these inches. So our area for this square would be 3 times 3, or 9 inches squared. Important to remember, anytime we're dealing with area, our answers will be in units to the power of 2, or units squared. That will show that we are dealing with area and not just a straight measurement. So 9 inches squared would be our area for that square in that example. Let's move on to rectangle. So with a rectangle, we know we still have those 4 right angles. This time we have sides across from each other are the same, but they're not all the same as each other. So you can see the sides that have 2 dash marks are the same. The sides that have 1 dash mark are the same. That's what makes a rectangle. Obviously, elementary knowledge there. You should have that down, know what a rectangle looks like by now. We're going to label these length and width. So we have the length of the rectangle and we have the width of the rectangle. So my area formula of a rectangle is just multiplying those two values, length times width. I use that cursive letter L so that it doesn't look like a 1. Please make sure that you are using lowercase l however you choose to show that. So we've got area equals length times width. Looking at an example for a rectangle, let's just draw one here, and we'll say that our length was 10 and our width was 4. So to find that area, we would just take 10 times 4. And this one, let's go centimeters for our units. So when we multiply this, we're going to end up with 40. Our unit is centimeters squared. That would be our solution. All right, moving on to parallelogram. Parallelogram. So this one's a little bit trickier. In a parallelogram, we have 2 sets of parallel sides, just like what you see here. We also have the sides across from each other equal to each other. So again, this and this will be the same. This and this will be the same. But the one thing that we notice about a parallelogram as opposed to a rectangle or a square, we don't necessarily have those right angles. We are going to find the area of a parallelogram. Let me change colors here. By taking the base times the height. Now, in a parallelogram, the base, pretty clear, is just the bottom of that figure. The height is where things get a little bit tricky. We want to make sure that we're measuring height from the base to the tallest point of our parallelogram. So the height has to go straight up with a 90-degree angle. That is our height. We do not follow the slope of the parallelogram. We want to find the true height straight from the bottom, straight to the top to find that measurement. So for an example, let's just sketch kind of a rough parallelogram here. We might know in an example like this that this is 8. maybe they'll tell me that this side is 5, and then they'll give me a height of, I don't know, 4. Okay? Now, in this example, you can see the 5 out here is talking about this side. That is a measurement we don't even need to do our area calculation. So sometimes you might have measurements that they're good to know, but they're not necessary to find what we need to find. We are only concerned about the base and the height of our parallelogram. So area here would be base, 8, times height, 4. So our area would be 32. Now, you can notice on this problem, I don't have inches, centimeters, I don't have any type of measurement, but I still need to label my answer. So if I don't have a measurement to use, we use the letter U. That stands for units. So units squared. 32 units squared. So again, if you don't have a measurement given, you can just use the letter U for units to label your answer for area. All right, if you need to pause and get this copied down onto your sheet, feel free to do that now. Otherwise, we are going to keep rolling with the bottom half. So if you need to pause, go ahead and do that now, and then we will keep going. All right, down to the bottom half. So we've got triangle, trapezoid, and circle left. Triangle. For a triangle, our area formula is base times height divided by 2. You also might see this written as 1/2 base times height. Either one of those is okay. We'll take the base times the height divided by 2. We will label this is our base, this is our height. Now, I'd like you over to the left of this to draw another example of a triangle that is not a right triangle. And over here, I'd like you to draw a weird-looking obtuse triangle that looks like, kind of like that. I can make that even a little bit wider, something like that. Okay, so we should have 3 triangles in this box. I want to do this because it's important to know that our base and our height could look very different depending on the type of triangle we have. So if we have a triangle like we have here on the left, this would still be our base, but we don't follow the side for our height. This is similar to what we talked about with parallelograms. The height needs to go from the base of the shape directly to the top of the shape in a straight line. So this would be our height for that triangle. Now, in that upper right triangle, this is still our base. It's the bottom of the triangle, but our height needs to go from the base to the tallest point of the triangle. So this height is actually going to fall outside of the triangle. That can happen. So this height looks like that. We want the distance from the base all the way up to the tallest point of the triangle. We don't follow the sides when we're looking at height. So make sure you have all 3 of these kind of laid out in your box here, just so we know that the height could look very different depending on the triangle that we have. So let's look at one of those kind of weird obtuse triangles for our example. So let's say in this example, our base was 10. Let's say they give us this side to be 20, and this side is 8. And then they give us a little height measurement, and usually this will just be given to you. They would say, hey, the height of this triangle is 6. So again, this is a situation where we have more measurements than we need for our calculation. We don't need the 8, we don't need the 6. We only need the base and the height. So to find this, we would take the base, which is 10, times the height, which is 6, and divide by 2. So I have 10 times 6, which is 60, divided by 2, which gets me a final answer of 30. Remember, if we don't have a measurement listed, we're just going to use the letter U for units. So 30 units squared would be the area of that triangle. All right, trapezoid. This is maybe the trickiest of our formulas, so make sure that we pay attention and get this down correctly. Okay, the area formula for a trapezoid. we take base 1 plus base 2 in parentheses times the height and divide by 2. Base 1 plus base 2 times the height and divide by 2. When we label this, we've got base 1, we've got base 2. This is kind of the funky thing about trapezoids. They have two bases. They have a top and a bottom. Those bases are always going to be parallel to each other. And then there's going to be two other sides that are not parallel. So these two sides are not parallel to each other. Those are not our bases. Those are just sides. The two bases are the top and bottom lines that are parallel to each other. We also will always have a height. And just like we've been talking about, that height needs to go straight up from the bases. So our height would be how tall that trapezoid actually is. So let's take a look at an example, and maybe we'll do one that looks kind of upside down like that. So in this example, we'll say that they give the height of 3. This is 2, this is 9, and then maybe they tell us that these are both 5. Okay? Again, measurements we don't need, those 5s, but you might have them, so we have to decide, okay, what measurements are we using and which ones are we not? So let's set this up. We've got our area equal to, we're going to add the two bases together, so that's going to be 2 plus 9. We're going to multiply times the height, which is 3, and then we're going to divide by 2. Let's say that all of these measurements this time are in feet. All right, so we take 2 plus 9, which is 11. 11 times 3, that's 33, and divide by 2. So we're going to find our area here to be 16.5, and our measurements in feet, so we label this as feet squared, or square feet, for our trapezoid area. All right, last example, circle. The area for a circle is, sorry, I've got to change my ink color here. Area for a circle is pi r squared. That r stands for radius, and the radius of a circle is the distance from the center of the circle to the edge of the circle. Okay, so if you have a line that goes all the way across, we would have half of that for our radius. We're just going from the middle out to the edge. Pi, we know, is approximately 3.14, but there's a bunch of digits after that. You should have a pi button on your calculator that you can use when you do these calculations. So, for example, on a circle, let me get a circle drawn here. There we go. Let's say that we are given the information that our circle is 10 yards wide. 10 yards wide. And I want the area of this. We know that the radius is only going to be half of that. So that would make this 5 and 5. So our radius here is 5. So when I set up my area formula, I need to do pi times radius, which is 5 squared. Okay, pi r squared. So on my calculator, I will take 5 squared, which is 25, times pi. Now, we have two ways we can show this answer. You can leave it as 25 pi. That would be an acceptable answer, leaving it with pi as part of your solution. You can also take 25 times pi in your calculator, which when you do that comes out to be about 78.6, I believe, something kind of close to that. And this measurement is in yards squared. So either one of those answers would be acceptable, to leave the pi there, so just 25 pi, or to figure it out with your calculator. All right, once you have this all copied onto your green sheet, you should now have the entire front side of this filled out and ready to go. You're going to use this sheet to do some practice problems that are posted in Canvas, just to apply these and find area of some two-dimensional shapes. When we come back next week, we're going to start working with three-dimensional shapes, and we'll use the back side of this graphic organizer. So make sure you keep this in a safe spot. You will be able to use this on the test, so making sure that we have these formulas all down and ready to go will be super helpful. All right, have a great weekend. Make sure we get some good practice on these problems in Canvas, and I will see you Monday.